This example asks us to use the vertex formula and the intercepts to graph f of x equals negative x squared plus 4x minus 4. So let's bring up the steps for graphing a parabola using the vertex formula. Okay, so first we want to determine if the graph opens up or down. Well, that's determined by the sign of this leading coefficient here. This is negative, so it opens down. All right, so there's that. The x-coordinate of the vertex is given by negative b over 2a, and recall that we'll need to plug that into the function to solve for y, to get that y-coordinate. Okay, so let's do it here. Negative 4 over 2 times negative 1, so that gives us positive 2. Plugging that into the function to get the y-coordinate, so we'll say y equals f of 2. Alright, so what is that? Negative 4 plus 8 minus 4. That looks like 0 to me. So we can combine these into an ordered pair to get the actual point, 2, 0. Alright, so there's our vertex. Let's go ahead and add that to our grid here. So 2, 0. It's right on the x-axis, which is interesting. Let's get our x-intercepts. Actually, we already have one right here, and maybe you can deduce what's happening, right? Actually, we already have enough information up here to graph this if you really think about it. But let's go a little bit further anyway. Let's go ahead and solve for the x-intercepts. So to do that, let's see here, x-intercepts. We set the whole thing equal to 0, negative x squared plus 4x minus 4 equals 0. Well, this is hard to factor with a negative in the front, so I want to factor that negative out. So that changes the signs of everything left behind. So x squared minus 4x plus 4 equals 0. Well, this is a perfect square trinomial, so this is actually x minus 2 squared equals 0. The only way this can be true is if x equals 2. So indeed, we only have one x-intercept, and it's right there. Well, how can a parabola only have one x-intercept? That happens when it touches the x-axis but does not cross it, when the vertex itself is right on the x-axis, which we already knew happened from when we found the vertex. So there's the x-intercept. Now let's move on to the y-intercept. The y-intercept is always this constant term hanging out with no x attached to it. So here's our y-intercept. You can always just go right to the y-intercept and also think of it as plugging in 0 for x. But here it is at negative 4. Let's go ahead and add that in on the y-axis here at negative 4. And since this is 2 to the left from the vertex, note that we always get a point for free, now 2 to the right of the vertex, right, because of the symmetry of these parabolas. So we have another point here at 4, negative 4. And that's a mirror reflection across this kind of vertical line here. We call this the axis of symmetry. Sometimes it's helpful to draw this just to remind us that there's a nice mirror reflection across this line. In this case, it's the vertical line x equals 2. So that should be enough to graph our parabola. Let's go ahead and connect these points up. Something like this. There we go. A parabola that opens down with a single x-intercept.